Welcome back to our constraint optimization class. So in this class, I'm going to show you how to use the second method to achieve the same thing like this under when we are dealing with constraint optimization. So I call it method 2. I'm going to show you now how to achieve the same purpose. This is method 2. So in method 2, what we are going to do is that very straightforward, you divide 2, this equation 2 here, by equation 3. You can see, so here we are going to have the first equation is this, okay? So we have x, y, okay? Then divided by fy, we have x, y, okay? So when you divide that, so we are going to write this, don't forget the equal sign. So put equal sign here. Just take, so you don't divide directly, just take this side, this one to the other side. So in other we have a lambda here, then also divided by we have b lambda. Can you see? So take this one to this side, okay, so that you can divide this, and also take this one, divide this by this, okay. So then the next thing is to cross multiply. When you cross multiply, you are going to, so this will cancel this, and it will now cancel lambda. When you cross multiply, we are going to have b f of, you have f suffix x, x, y, okay, equals to a x suffix y, x, y, okay. So you are going to solve this. You make either x or y solve the formula and you substitute into the equation 4. So you are going to get the optimal value of x and y. In fact, you can also get the optimal value of lambda if you are looking for that. Okay, now let's take a look at an example of this. We ask example where we are have to minimize the firm's cost function. C equals to, we have 5x squared plus 2xy plus 3y squared plus 800, subject to x plus y equals 39. So we are asked to minimize this. So meaning that we are going to find the value of x and y that will minimize this function, given that the firm will not produce beyond this. That is not going to produce the total output beyond 339. Okay? Alright. Now, so how do we do that? Very simple. So we are going to set up the Lagrangian function like you were taught in the previous video. So set up the Lagrangian function. So set up the Lagrangian function. So here is f. So the function I'm going to minimize will come first. So I'm going to have 5x squared plus 2xy plus 3y squared plus 800. Okay. Then I'm going to introduce a constraint parameter. So I say plus lambda. Then in bracket I have 39. I take x to the back. I have minus a and minus y. Then I have to find the partial derivative of this function with respect to x. That is the partial derivative of x with respect to x. If I do that, I'm differentiating with respect to x only. So if I differentiate this, I'm going to have 10x then plus, if I differentiate this, I'm going to have 2y. This one does not have x, I ignore it, I ignore this. Then I move to this. If I differentiate this x in the bracket, I'm going to have minus 1. Then minus 1 times lambda is going to be what? Minus lambda. Then I set to 0. Okay? I set to 0, so I can simplify this further if I like. I can say 10x plus 2y equals lambda. Okay? So I can call this equation 1. Okay? Now, if I also have the partial derivative of n with respect to y, so that way, now I'm different with respect to y. This one does not have y to go away. This one has y, so I'm going to have 2x, then plus, differentiate this one, I have 6y. Then here I have minus 1. If I differentiate minus y, I have minus 1. Then I have minus lambda, okay, equals 0. Then I can simplify this further to be 2x plus 6y equals lambda. So I can call this equation 2. Okay. Then I have the partial derivative of Lagrangian function with respect to lambda. So that will give me everything in the bracket. It's always what we have in the bracket. I have 39 minus x minus y equals 0. Then this is, then I can also simplify this further to be, okay, I have x plus y equals to 39. So let me call this equation 3. So like I said, there are two ways of solving this, okay, that is of making this equation and this equation. What we are going to do is that I'm going to do next is that divide equation 1 by equation 2. So this is equation 1. So I have 10x plus 2y, then over 2x plus 6y equals lambda over lambda. Okay, this lambda cancels, so we have 1 over 1. Then we can cross multiply. If we cross multiply, we have 10x plus 2y equals 2x plus 6y. Then we collect the like terms. Okay, we can have 10x minus 2x equals 6y minus 2y. Then have 8x equals to 4y. Okay, now I can say we have 8x over 4 equals to y. Then we have 2x equals y. Okay, this is 2. So I can call this equation 4. Then the next thing is to substitute equation 4 into equation 3 here. Wherever I see y, I plug into x. So I have x plus y. That's y is 2x equals to 39. Then I have x plus 2x, that is 3x equals 39. So I have to divide both sides by 3. So this divided by 3, this divided by 3. Okay. Anyway, so what do I have? I have x equals to 1, 3. It's 13. This is the minimum, okay, value of x. So in order to get the minimum value of y, so we substitute, that is plug in x equals to 13 in equation 4. So I have 2x equals y, then I have 2 into bracket 13 equals y. So therefore we have 26 equals to y, that is y equals to 26. Okay, these are the optimal value of this, that is the value of y and x that minimize this function. Okay, subject to this constraint is this x equals 13 and y equals 39. Okay, you can cross check. So 13 plus, so this is 26, sorry, y equals 26. 13 plus 26, that will give you 39. The constraint must be equal. Always cross check. If your answer is different from 32, from whatever figure you have here, know that something is wrong with your calculation. See you in the next video. Thank you.